Right. Good morning, everyone.
Good morning.
Thanks for coming to your fourth day of Ignite. Tons of exciting stuff so far. So no better way than start your morning with a 400 level session to go deep into the details. And this is something new that we're doing. We've talked about functions a bunch at Ignite and previous conferences, but we feel like we haven't really gone in and show you how things work under the covers. A lot of you, appreciate the fact that we're open source and we're very transparent what we do. Our issues are on GitHub, but we don't expect folks that use functions to, open our source code and understand how the functions runtime works. So we feel like doing this here, we can really explain how things work, give you a better understanding of the platform. So with that disclaimer, just to be clear, we're going to go pretty deep, pretty quickly. We're going to do just a little bit of overview, but right. We want to go into the details.
Yeah, we have a lot of ground to cover, so we are going to move a little fast. And to add to the disclaimer here, there is some expectation that you are somewhat familiar with Azure Functions. We are going to dive into the runtime and expect some familiarity with the runtime. So I just want to leave that warning there. We hope that is the case, but if not, I hope that you still take something away and you'll learn something from the session.
Yeah, absolutely. And just a little bit about us. Both me and Fabio, we are on the product team for Azure Functions. I'm the product lead, and I've been on the platform as a service, or this high level of abstraction of the cloud since I joined the Azure team about 5 years ago.
And I'm one of the developers on the Azure Functions team, mainly focused on the host, on the runtime, and some of the web jobs and bindings functionality.
Actually, super excited to have Fabio here. Actually, he spends most of his time coding on the functions runtime. I think personal and work time, that's probably all that I know that he does. We have a pretty similar background. I don't know why both of us end up in Seattle, coming from a beach city in Brazil, but I thought that was an interesting fact. All right, so let's talk about what we want to cover here. We're going to go really brief into functions, just to recap, make sure everybody's on the right session. And then we're going to spend probably half of our time here on Functions 2.0. We're going to talk about why we went on this journey. We had, a pretty good product, and why did we decide to do a new rev of it? We're going to what's included in Functions 2.0, so it's clear. And mostly Fabio going to how things work, really the under the covers piece. With Functions 2.0, enable us to do more things, so we're going to the different hosting models that we now support. We'll talk about the tooling, how things changed. Couldn't be a functions session without talking about durable functions, right. Part of the product that people love. And in the end, we give you some references, so a lot of this you can use it later, refer to it later. So just the usual Azure Functions slide in case you haven't seen it. So what is Azure Functions? It's your compute that reacts to events. The events can be either event from event source, like Event Hub or Service Bus, or something that happens in storage, or it can be an HTTP request. Functions let you define your code in your preferred programming language in your environment. It can be C#, F#, Node, Java, and we'll talk about all the languages we support. Once you define your code, it can take input and output with the concept we have of bindings, which lets you abstract from other APIs that you want to use in your code, and makes it really easy for you to program and interact with other services. That's basically functions in 30 seconds. And where functions is in the whole Azure ecosystem, we all talk about serverless, and there's a lot to serverless. If you want to build an application, it's not all about functions. Functions, obviously, is the centerpiece if you want to write serverless code. But a real application, you need other components. You need an eventing platform, such as Event Grid. You need to be able to talk to data. So you could use Cosmos DB or other Azure storage products. You could do intelligence with cognitive services. And all of those services that I mentioned, they're all serverless as well. So if you want to build serverless application, you combine those things together. The other way you can do compute in serverless is with logic apps. That's a design-first approach where you can create your orchestration workflows by simply doing drag and drop. They have over 200 connectors, a great way for folks to develop a serverless application as well. And logic apps can call into a function if you need custom logic.
So a lot of services on Azure to build a full end-to-end serverless application.
Absolutely. But what really differentiates us, and we get reassured by the analysts, is what's on your left, which is our development tooling. The fact that we're in the same company that does Visual Studio Code and Visual Studio helps us work really tightly together to put up an experience that's very rich, or monitoring application insights, which is another thing that I love about functions and the Azure ecosystem.
And our tooling support is definitely something we're really proud of. So before we move forward here, I just want to do a quick check. How many of you are currently using functions? Okay, good show of hands. How many of you have had the opportunity to use the Functions 2.0 preview? Great, thank you, by the way.
Well, that's good, because we're going to cover the differences. So it's good for those of you who haven't tried 2.0. Well, we're going to see why 2.0 is interesting. But before we went into 2.0, what were the challenges 1.0? About fall of 2016 is when Functions 1.0 went GA. We saw adoption growing and becoming really popular, but at the same time, we start getting some feedback and noticing a few issues. We got customers that wanted to do Java functions. We didn't have support for that. There are customers that wanted to do Python and PowerShell, and we had an initial support that really lacked some core functionality, like bring your own modules, rev into new versions. So we felt like our extensibility model for language was not quite there. The first version we did, we could only host on Windows. So if you want to deploy or bring a container or bring dependencies that are native to Linux, you couldn't do that. You could only develop on Windows because the 1.0 runtime was on .NET framework. And for .NET developers, how many of you are .NET developers? So seems about the majority are .NET developers. So for those of you who use Functions 1.0, you might have faced this, which is you had some issues when you're trying to bring your own assemblies into your code that could potentially conflict with our runtime. And lastly, we had some performance issues along the way. We always want to make things faster. The workloads coming to functions also start getting larger, and we felt like we need to optimize more our runtime. And lastly is, although we differentiate on user experience and development experience, we felt like we didn't guide customers well enough to use the local tools and everything that's available in your dev environment. So there's another thing we want to fix in 1.0. So with all of that in mind, what did we do? We went on a 2.0 mission, which is now generally available. And we're super happy about it.
Yes, yeah, absolutely. It's finally here.
It's a long time coming for us with developing it, because we are fully supporting 1.0 at the same time, and we take on some massive changes, and it's going to be very clear some of the things that we've done, and Fabio's going to go into the details of those. But the announcement includes a bunch of things, so we feel like covering one by one so you know all that's there. So to address that problem that I mentioned, that we didn't guide before customers well enough to use the local tooling for either development or deployment, inner loop or outer loop, we added some quick starts. So now when you create a new function app and you want to do a plus new function, depending which language you picked, we give you a tailored experience for that language that tells you how you can succeed, either Java or Node or .NET.
So setting you up for success in the long run, right? So
absolutely,
have something that's maintainable.
And something I want to show here, like the session, if you're not there, you can watch the stream. The session on Tuesday that Jeff and Matt had went through some of this that you can notice. And it's live too, so you can experience by yourself. The runtime, and I mentioned briefly, we were on .NET Framework before. Now the 2.0 is .NET Core, and that's cross-platform. So that's what allows you to develop on a Mac or Linux and also deploy to different host environments that are Linux-based or Windows-based, or even some of the IoT operating systems that we can run.
Yeah, huge benefits from that. Cross-plat support, the performance benefits that we get from it is just a huge change. So .NET Functions loading changes. Eduardo mentioned some of the issues that most of you or some of you are probably well familiar with dependency conflicts. We had workarounds, but it was something that was painful in V1 and something that we definitely wanted to address in V2. So we did a lot of work to make that better. A new extensibility model, which kind of plays really well with the function loading changes that landed. So we now have a very clear, well-defined extensibility model for bindings, for your extensions, and language workers, which we'll get into later in the session.
The other one is when we talk about deployment, we want to make, we had some issues with deployment. Some of the methods that folks who are using for deployment doesn't give you all the deployment benefits. So we have functionality to deploy code, run code from a package that's much more efficient. And I'm going to demo that, go into the details. And that's also, it's sort of under the covers for most customers that use our tooling. But it's a technology that's worth highlighting as well as something that's also included in the general availability announcement. And we updated our tooling, so the tooling now all support 2.0. You're going to see our demos are the 2.0 demos, and we're going to use some of these tools. So they're all updated. The other thing that's not included there is some of the tooling that we now support for the new languages. Like, let's say, Java. We can do things with IntelliJ and Eclipse, and we integrate with Maven. So we keep trying to add the tooling support to the language that's appropriate for you or for the workload that you want to bring to functions. And durable functions was already GA on 1.0. And I add this here to clarify now, with 2.0 being GA means that durable functions is also ready for your production workload in V2 as well. And one of the differences there is now you can do JavaScript. JavaScript itself for durable is in preview, but the C# support is generally available.
GA, day one GA with Azure Functions 2.0.
And that's one change we made, but not everyone noticed, so I feel like calling out, which is we have an SLA even if you're running consumption. We had an SLA before if you're running on an app service plan, also known as dedicated mode. But now if you go to consumption, we ensure 99.95 SLA as well. So a lot of enterprise ask us about this. It's for some of them, they need that guarantee on the platform for them to come to us. So
that's a pretty unique thing in the serverless compute offerings.
As far as I know, so we're the only ones that are doing this. OK. So now, if you're using 1.0 and 2.0, we have a lot of documentation that goes through what the differences are. So we picked the main ones to put it here, so you really know how things changed, and we're going to cover them. Start. You want to cover?
Right. So yeah, this is not a comprehensive list. We just wanted to call out some of the key differences between the two runtimes, the two versions, differences that are worth keeping in mind. So as we mentioned, we've moved from .NET Framework 4.7.1, full framework, to .NET Core. So your runtime, when hosted on Azure, it's going to be running and local is going to be running on .NET Core 2.1. We have a stronger assembly isolation model, and that's something we're going to be diving into later in the session as well. We've done a lot of work to enable revving and different release cadences for all of our binding extensions, giving you a little more flexibility as to which version of different SDKs you want to use, when you want to upgrade your bindings.
And on language as well. In the past, we're tied into specific versions of languages. That can be a particular problem to languages like PowerShell support, where new versions come up pretty frequently. So now we'll be able to do a model that we can develop the support for new languages while the runtime can progress independently. So allows us to bring in new versions of languages rapidly and be able to rev to new ones. One of the examples of that is for Node JavaScript 1.0, we're stuck into Node 6. And on 2.0, now we support 8 and 10. And if there's a future version, we'll be able to bring that in with this new language extensibility model.
Yeah, it's a lot simpler to do that. And we can do that in a way that's really reliable without worrying that we're going to break anyone in the process.
Absolutely.
Yeah, for Node devs, just out of curiosity, again, how many Node developers, how many people running Node on functions? Okay, so a few hands. Yeah, one of the limitations that customers usually often ran into is the fact that they couldn't run native modules. They have the ability to do that now with the changes that landed.
Yeah, and on HTTP triggers, which this is one difference you might notice is we had HTTP triggers and we continue to have them. And if you notice, we had these specialized webhooks for GitHub and some other sources. So now you're not going to see this. You're only going to see HTTP. But you can still use your HTTP functions to work as webhooks.
Yeah.
The language runtime, one change you're also going to notice is as you create a new function app, we're going to ask about which language runtime you want your function app to support. In the past, there were multiple languages on your function app that you could run. But now, with us asking you which language runtime you want up front, we don't bring the other dependencies into your function app. And allows also the tooling to be, when you use VS Code, to really target that language that you picked.
So you have an experience that's really optimized for that language, that workload that you wanna work with.
Absolutely. The other functionality we have for routing and composition of your API, we have functions proxies. That was already GA 1.0, just like Durable, continues to be GA in 2.0. The Open API functionality we only took it to preview 1.0. It's something that we're going to be working on it to bring it to 2.0. In terms of monitoring and observability, we have application insights, and we've been betting more and more on that. We actually made it, I think one of our releases about 6 months ago, application insights being created by default, so you can associate that with your function app. So more and more rely on application insights, and if you're using functions in a serious manner, you should use it. The one that we're going to stop supporting is the web jobs dashboard, right, for some of you that might be familiar with it.
Yeah, the storage-based monitoring and logging feature is no longer supported in 2.0, but we invested a lot of time with the application insights, in the application insights experience. There was a great session earlier this week from Matthew Henderson and Jeff Holland, and they walked through some of the monitoring capabilities. So I'll highly recommend referring back to that session. And if you have any questions about logging specifically, we'll be at the booth as well.
All right, so these are just a comparison of which bindings were available 1.0 and then 2.0. So we had a lot in 1.0, these native bindings. And one thing that you're going to notice is some of the bindings that used to be native, we couldn't really rev and update its versions. Now we have a model with the binding extensibility that in 2.0, and if you see the little version numbers on the right, that these things can be versioned independently of the runtime. Back in 1.0, they were native, so we have to change the runtime to make changes to them. Now they all get developed separately. One thing that's been happening almost like organically is other teams that contribute with us, not just the functions runtime, and they're helping create some of these bindings as well, and they can develop them at their own pace.
Yeah, they're already taking advantage of that extensibility model that we mentioned. We have good examples here, like the SignalR service.
Yeah, that's a fantastic one.
That team worked very closely with us to bring the binding. They very quickly had something integrating with some great functionality added to functions.
All right, assembly probing and
So
binding.
let's dive into the tough issues here. So I wanted to talk a little bit about how we went about tackling the assembly probing, binding, conflict, dependency issues that we had in V1. This was actually a combination of a lot of different things, a lot of different changes that happened in the runtime. The first one was actually us leveraging some new capabilities introduced in .NET Core to enable us to provide better isolation between runtime assemblies, runtime dependencies, and the dependencies you are bringing in. So everything all of the assemblies that you bring as part of your functions. We use what is called an assembly load context, a custom load context with a lot of work that was done there to make sure probing and binding behavior works as expected, but you have a much stronger isolation between what's in the host and what's coming from your function, what you are deploying, without giving up all of the benefits that you get from the bindings. So you still get the rich type binding behavior. You can still bind to rich types and take that as input and output, while still taking advantage of that clear separation and being able to bring your own dependencies in. I mentioned the improved probing and resolution logic, the behaviors, so that layers on top of the assembly isolation work that was done. We work on top of the artifacts that you're deploying, the assemblies, the binaries that you're bringing in, as well as the depth file that is present, principally in the case of dynamically compiled, the CSX model. We perform automatic resolution of platform-specific and native dependencies. This is something that some customers have struggled with in the past with V1, although it was supported. There were some cases where it was tricky to get it to work, and we had to help people along. It's now really straightforward in V2 to perform, to deploy and have dependencies on native and platform-specific assets. And this is consistent with the model you find in .NET Core. So that's not something that behaves differently in functions. It's something that if you're developing an ASP.NET Core application, a .NET Core console app, it's a very similar behavior there. So it's consistent with that model. So we've also improved the extensibility, as we mentioned a few times already, and we've consolidated the load behavior, which helped with a lot of the conflicts and the issues that we had when loading dependencies. We'll be able to illustrate that here in a minute, but we had a few different models on how extensions and bindings were brought into your function app. As you alluded to, some of those were natively and statically linked from the runtime, so we had hard dependencies on some versions of the assemblies, and those were loaded using one mechanism. We had a concept of extensibility in V1. Durable functions actually took advantage of that. So that was yet another model of loading dependencies, loading assemblies, loading extensions. So we've consolidated it all. We have a single model that does everything the way it's supposed to be done. And it's a lot easier for us and for you now to maintain things loaded where they're supposed to, and to deal with extensibility and bring in those bindings and extensions. And one thing that we wanted to touch on, this is not a GA item. It's something that we've talked about in the past, so we wanted to make sure we called out here. But it has, I'll be honest here, it's a lot lower priority today because of the results we're seeing from all the work that has been done to address all of the binding issues and the assembly resolution issues. An option we still may want to consider to expose, to developers with edge cases and more advanced scenarios is to leverage the same language extensibility model that we're using for JavaScript, for Java, and have a .NET worker that will allow you to own the process. So you would own main. At that point, you can do whatever you want. It's your process. So I have a simplified version, a simplified diagram here to illustrate how things worked in V1 when it comes to bindings, specifically extensions, how that changed for extensions, what we've done. And I think that will help principally some of the people who follow the repo and has seen all the work happening there, and have seen some of the changes that were made on how you're now required to reference the extensions you wanna use, as opposed to having them out of the box. This will help you understand why. In V1, we had the job host, the bindings, and all of the runtime dependencies loaded into the same context, same process, same context. This is a simplified view, so we're talking about the precompiled model. In the case of CSX, it works a little bit differently, but to simplify, we load all of your assemblies into the load from context, the functions assemblies, and all of the functions dependencies. A very common issue that we would see is that the runtime had a dependency on the Azure Storage SDK 7.2. If your function dependencies, by default, if you created using VS, you would have a dependency on the same version. If you had code that looked like this, and you were taking a dependency, you're taking an input parameter that came from the binding, there was taken in a cloud block blob, with this scenario, everything would work just fine. What we would often see is that you go to NuGet, you see there is an update, you see there is a newer version of the SDK, you want to update that, you move on to a newer version of the storage SDK, and things would start to fail. So what we've done in V2...
I love this animation. This is some artwork there.
It was harder to do that than
do it again.
the actual binding work.
So the binding is actually moved to the user piece. I love this.
So what we've done in V2, as Eduardo made sure we saw again...
I'm really contributing to this part of the presentation.
We moved the bindings to the same load context as your function. This context also has a much better isolation model, a much better probing. The resolution logic has been significantly improved. But now you deploy those bindings as part of your function. So when you deploy your dependencies, when you deploy all of your assemblies, those extensions, those bindings are actually part of the same deployment unit, the same package that's being deployed. And what that means is that you really bring in whatever version of those assemblies that you want to use, whatever version of the bindings you want to use. So in our case, in V2, we've updated our dependency. We also want to be on the latest and greatest. So we've updated to the latest version at the time of the storage SDK. Again, if you're using the same version of the storage SDK and you had code that looked like this, things would work just fine. If you decided to upgrade to a newer version, let's say the storage team decides to release a 9.5 or a higher version, it would have the ability to upgrade. More importantly, we would have the ability to actually adopt those new versions of the SDK and release a new version of the binding that works with those versions as well. So if there are new APIs, new functionality, you'd be able to take advantage of that without having to give up on the binding capabilities. So you wouldn't have to break into the SDK to use that.
That's awesome stuff. There's a lot of people have been waiting for that. So yeah, those are great. So talk about language extensibility, just going a little bit deep so you guys understand how it works under the covers. So here's the 2.0 model on how language extensibility work. You can see right away that you have two different processes. So the runtime is the host process, the one you have on the left. And that one is where you're going to receive all your events or HTTP requests. And in the script host, what's going to do is going to do inter-process communication to communicate with the language worker process. And that can be in any of the languages we support. The only language that Fabio mentioned that runs in the host process would be .NET. All the other languages, they run on a separate process altogether. That gives you some advantages. Now, you know, if, say, your language process crashes, then the host doesn't bring down the host, can potentially increase reliability that way. In terms of development process, allows for all these different workers to be developed without having to touch the host. So we can have different teams. Actually, one that is not here, but you're going to see a demo tomorrow. There is a team working on, let's say, the PowerShell support, and that team can progress on that while we still focus, the runtime still focus on the runtime piece. So the other one I want to talk about is that now that you have this here is when I mentioned earlier, you can bring all the different versions of the languages. So you can have different versions of the worker even for a given language that you have.
Right, and it allows us to iterate very quickly on those as well, right? So if we're bringing in a preview language, we don't have to be so concerned about potentially breaking customers who are not even running that language because it's not built into the host anymore. So it's an opt-in. You decide to use the language worker. It's brought into your environment, and you get a new feature. And customers who are not using that don't have to worry about that capability.
Talk about tooling a little bit. So we still support all the same set of tools that you come to love with Visual Studio Code, which is typically the one that gets the most applause when we do the presentations, or Visual Studio, or the command line tools. So you can have a runtime running from a command line, as well as if you can do things from the portal. And if you have more administrative type of actions you want to do on your function app, you can use Kudu. That's this cloud Swiss Army knife that you see there. And I'm going to use it later for one of my demos. And we added more deployment options. Like we mentioned on the session on Tuesday, we went over a lot of what we're doing with Azure DevOps and the outer loop stuff. But even when you just want to send your code to the cloud, to a function app in the cloud, we're trying to make the deployment options more efficient. And we invested on this new functionality, but before I talk about it, I'll just mention some of the problems we had with the existing deployment options. Because we're built on top of app service as functions, and we support all deployment options we had in app service as well. So we had things like, let's say, FTP, where you can deploy one, you can put your files on production one at a time. So what can happen there is your deployment might fail in the middle of you sending all your files. Out of a sudden, you have your production side in an inconsistent state, where only half of your files have been updated. The other problem is while you're trying to update those files, one of them might be in use, prevents you from updating it altogether because it's locked and your deployment's hosed. Common scenario that we see from customers is they want to go from a single repository, a single point, and deploy to all their global regions where they have functions app running the same version. So if you don't have one deployment that can really work as soon as you do that switch and send the deployment, you can have inconsistency of one region running one version, the other region running a previous version. And lastly is, even after you deploy, if you deploy some bad code, you just want to go back to another version, it's hard to do. So for all of those, what we've done is invest in this functionality where we can run your code from a package, which is a zip file, and that zip file can be hosted, let's say, in Azure Storage, external to your app, or you can add it inside of your app. And I'm actually going to demo that so people can see it in action.
Great. Yeah, pretty exciting feature here. This also provides tremendous benefits when it comes to cold start, right?
Yeah. How many of you had problems with cold start or know what cold start is? So some of you might be familiar. So if you have, let's say, a very large node app that brings tons of modules, and that's the part of sort of your app cold start, right? Because your app might have tons of things. What I've done here is I deployed one app that has literally 30 megs of node dependencies and 15,000 files. And if you're just trying to run it without run from package, you're going to see it's not returning. It's going to take a while because all of that has to be loaded. That's tons of I/O that has to happen on the disk. Now I have another version here where I pointed to a zip file that's in storage. And now this is going to get mounted, and my app is going to access that mounted file and doesn't have to truly do I/O. And this one returns in 7 seconds. And then I have another flavor of it where you can host a file within your app. And I'll show how that works under the cover. So you can set it up for yourself. And
to clarify, those are the same different versions of the same app.
Oh, yeah.
A huge dependency tree, just a lot of files to load.
The same app. And the previous one, you've seen those here are already done 6 seconds and 7 seconds, while this one's still running. We'll come back to it in a bit. Maybe it will finish. OK. So one of them that I ran, and I'm just now on the Azure portal, and I opened that function app, the second one I clicked on that I said the zip file is stored externally, all you have to do is you have to add this setting here and point to the file that you have. This is just a storage SAS key that points to storage and has an expiration and points to that file. That's one mode you can run. The second app I had, I just say, hey, website run from pack 1. What that indicates to us in the platform is you have that file within your function app file system. And you can visualize that. If you're not familiar with Kudu, that's your sort of admin tools that you have on your site, and you can navigate through your file system. And if you put this data on your data site packages, you can put your site there. And then with its package name.txt, you can say which version of your deployment you want. So one thing that I can easily do is, and I'm going to go back. This one is this app right here, right? And I'm going to switch a version. Let's say I want to switch to a different deployment I've done. And I pre-uploaded a different zip file here. All I have to do is if I want to change my deployment, and that can be very useful in a rollback case, is just to point to a different zip package.
So you're just mounting a different zip, a different file as your file system, as your site content.
Exactly. So the platform knows how to detect that the package name got changed, and okay, now it's pointing to a different deployment, if you will, and loads that up.
Okay, so we're just loading a different version of the same app here. I'm assuming there will be a different response or something different coming back here.
Yeah, that's what should happen when when things work. But yeah, I pointed just to a different version, so you're going to see that the output here is different because I have a different JS file. But changing the deployment was super easy. What's even better for most of you is you don't have to worry about this feature. It just runs. We integrated with Visual Studio Code and Visual Studio.
Right.
So this is going to be the default method. But so the lesson here is, kids, don't do FTP for your deployment. Don't do the methods that can break your site. Try to use some of these more advanced features that are better for reliability of your deployments.
That's great.
Yeah, and let's just check if that one ever ended. So this one was 100 seconds. So it's over 10 times better when you use a feature like this if you have tons of dependencies. So definitely helps with cold start of your dependencies. All right, I didn't switch to the demos line. We've done this demo.
All right, so we've covered a lot of stuff here. So I think it's time for us to do a quick recap.
Yep.
So Azure Functions 2.0, now cross-plat, thanks to the migration to .NET Core. We run on Windows, continue to run on Windows, Mac OS, Linux, and we have a lot more possibilities with that runtime. Enhancements to the assembly binding and probing. Those issues have been addressed in 2.0. We've decoupled bindings and extensions, so you now have a lot more flexibility on how you want to deploy and use extensions. Talked about the language extensibility model with the auto-process language workers. Talked about the additional deployment options that we have now with what you just demoed.
Package, yep.
Yeah. No tooling options.
Yeah, we mentioned some of them, and yeah, and just to reemphasize that point, which is we keep bringing tooling that's specific to your programming language, so it feels really native to you when you develop in your language, so you don't have to learn all these new concepts. So Java, I think, is the best example. Like if you're a Java application developer, you want to use Maven and some of your own tools, so we integrate with those.
So something that's familiar to me. New languages landing in the runtime as well.
Yeah, we're going to show a few later. I think to clarify our roadmap a little bit is we have the GA languages, but the next language we're getting close to GA is going to be Java. We have Python that we announced a preview here at Ignite. There are a bunch of sessions that Asavri ran and went through how Python works. I'm going to show this a little bit here today as well. And there's some languages that are in the works. So there's a session tomorrow as well that Kobe's running that shows some of that.
Closing a very important issue.
I don't know what this is.
So this is an interesting item that we wanted to have on the list here.
Let's switch to yours.
Yeah, it's not often that the engineering, the product team will know an issue by number. So if you walk around, a lot of us will be referencing this issue that talks about some of the assembly binding. This is what we use to track the assembly binding probing issues that we had in V1. Many of us know the issue number by heart. We just refer to this issue as issue 992. And if you're ever bored, you can go through this. GitHub is kind enough to collapse some of the comments. But it's a long thread. We spent a lot of time working with people here.
There's a lot of emotion on this thread, too.
Absolutely, yes. And we spent a lot of time providing workarounds, trying to provide guidance, trying to help people. But we also spent a lot of time listening to getting feedback from you. A lot of people provided a lot of help with different scenarios, things that they were trying to do that didn't work very well. And that really helped us address this issue. We've collected every single piece of feedback here, every scenario, every repo you've shared with us, and we worked hard to make sure that this was all addressed. So we thought it would be very fitting to close this issue live today, with all of you. It's an issue that was painful, but we're very happy to be here and be delivering to you now something that we can recommend for production that addresses the problem. So
you should say that we code reviewed with like hundreds of people live on stage.
That's right. You all approve, and let's go ahead and close this. So we're going to call this resolved. And really thank you for all the help along the way and the patience. We appreciate that.
Okay. That was awesome.
Yeah, a lot of engineering work has gone into 2.0 as well to enable some future scenarios.
Yeah, I think what we're excited about as a product team is 2.0 is one that we work for quite a bit, and in some ways, what we're really happy about is what that enables, like the fact that it's cross-platform, all the new programming languages, all the things we're talking about, like how we can get sort of disassembly loading problems behind us and move on to new problems and focus on, performance, reliability, a lot of other core things that we want to do. So 2.0 is really an enabler for us to do a lot more things. There's no 3.0 coming, as far as I know, but so we can really focus on features and a lot of things and customer. You looked at me like you have plans for 3.0.
3.0? No.
So that's one thing that's exciting, and we want to spend at least some time in this session talking about some of the upcoming stuff, things we're talking about.
Right, and I think this will help. We have a lot of folks following the repo, right? And they saw a lot of work happening, and we did hear a lot of people asking why. Some of those features are not immediately apparent with this GA. Some of the things some of the work that we've done is really preparing us for some of the features that we are going to now be able to deliver now that 2.0 is out. One of the things that we hear a lot of questions about is dependency injection. If you were watching the repo, many of us, a lot of the team members are here. We've been working hard on dependency injection. This is something that WebJobs customers, which, by the way, WebJobs is GA as well. WebJobs SDK has been released with Functions 2.0. So WebJobs 3.0 has been GA'd. WebJobs customers can already take advantage of this. The dependency injection work was done there, and they have a lot of flexibility on how they want to deal with service injection. But I wanted to show a little bit of the scenarios that this will enable in functions. And this is something that is not long-term. This is something that's going to be happening very, very soon. I just wanted to give you a quick taste of what you'll be able to do in functions now that this work has been done. So what I have here is what looks like the out-of-the-box template that you would typically see when you create a new function using the Visual Studio tooling, just an HTTP trigger. For those of you familiar with the functions model and the templates and the different trigger types, one of the things that you will notice is that this is not a static method. This isn't a static class. Okay, so I have a class here that has an instance method. I also see that I have a constructor here that is taking a dependency on a service called iMyService. This is an interface that is defined in our project. If we take a look, we have a simple implementation here of my service that just returns a new GUID every time the type is created, that class is created, instantiated.
So custom, the runtime doesn't know about this.
Oh, the runtime doesn't know anything about this, right? So we have that property. We're not newing up that service as part of our function. We are just taking it in as a dependency. And you'll see here that we have this function startup code that will be invoked by the runtime, giving me the ability to inject services. So in this case, I'm injecting this service, this instance of an iMyService, the concrete implementation being my service, which is what we just looked at, and I'm injecting that as a singleton. So I expect that a single instance is going to be passed to all of my functions, all of the function executions. So let's go back to the function here. Let's run this. So I'm just running the functions CLI, the function core tools. We get the service URL. I actually conveniently name all of my functions the same thing, so I can just go to Postman, and I have function 1, the URL already here.
It's a solid name, function 1.
I'm creative, yeah. And we see that an instance of the function type is now being created for me. So as part of the activation, I'm also getting an instance of my service. If we look, we see what that ID looks like. If I let this go and look at the response, you will see that what we're also doing here is creating a new GUID that identifies that instance of that particular class. So every time we have a new invocation, we have a new instance of the function class, but the same instance of the service is going to be passed in. And we can validate that on the response, on the HTTP response, we simply just return the ID of my actual function instance and the ID of the service. And you'll notice that the service ID remains the same, remains static, while the function ID changes with every invocation since I have a new instance of that class. Something else that I wanted to point out is that you're not limited, you won't be limited to your custom services as you take advantage of this feature. We'll be working on documenting a lot of the services you can take dependencies on, and that's one of the reasons why the feature is not in GA today. There's some work still to be done, but one example of that is I'm taking a dependency on iConfiguration here, and I have access to the configuration that is used by the runtime. So this is all of the configuration that was that is coming from the app settings you've defined, your local settings file, your host JSON, and I have access to all of that information from my app. I can dig into the configuration and use that in a very straightforward way, which is something that customers have asked us for in the past. So, giving you a little taste of what dependency injection will look like in functions. Hopefully that answers some of the questions about the whys and gives you a better understanding of why, how and why some of that work around dependency injection was happening in the runtime.
You want to keep demoing?
Sure. What do we have next?
What about you debug the functions host for fun? Get into the source code of the functions host from the user code. Is that possible to you?
It is. Well, it is a functions internals session, right? So I wanted to.
I think that's proper, yeah.
Yeah, for most of you, when you're debugging a function, we had a breakpoint in our function here. So we were stepping through our code. We saw what happened. We didn't really see what happened before that the execution hit our function, and we don't really see what happens after that. So if you run into trouble, if your code is surrounded by a bit of a black box, you don't know what's happening, it may become a little difficult to troubleshoot and debug what's happening. So let's switch back to VS here. I'm just going to open up a new VS instance. And we're going to create a new function from scratch here. This is actually highlighting another feature of .NET provided by the .NET team. That we're leveraging. We've been doing this in Functions 2.0 since the early betas, but I wanted to highlight these capabilities since it's something that a lot of people are not familiar with. We are open source, so all of our code is on GitHub, but oftentimes it's not that easy for you to just go clone the repo, build the runtime, and replace what we provide with the bits you've compiled, so you can debug into the runtime to see what's actually happening. So what we do is we use something called SourceLink, and we actually embed all of our PDBs in the assemblies. So when you're loading the function runtime, the web jobs SDK assemblies, you have all of the symbols. You have information about where the source code lives, giving you the ability to very easily, from Visual Studio, debug into the runtime itself. So
that's the famous function one.
Yeah, it makes it easy. I don't have to change the URL. I didn't even have to copy it. But here I have a breakpoint in my code. I'm looking at my function, but I see that both my stack is all lit up here. I can actually click on a stack frame. I'm going to be prompted with I'm going to be presented with this dialog, giving me the ability to download the source and continue debugging, and just say, yeah, I want to download, and don't ask me again, just do this every time. And now I'm actually looking at WebJobs SDK and functions code. So you are now inside of the functions code in the runtime. And you can step through as if it was your code. You can attending to this, you can continue to debug. At the very end, you could step into it, and all of a sudden I'm back into a different class inside of the SDK, inside of the runtime. So if you want to understand what's actually happening, if there is a failure, if you enable, if you want to see where an exception is taking place, we truly hope that this makes that process a lot simpler, a lot easier. We try to be really open. All of our issues are on GitHub. Our source is open source. We hope that this just helps with that openness. And if you're using this and you happen to find an issue, please submit a PR. We are happy to take contributions. If you think that you can improve on how things work, this will hopefully make that easy as well.
Fantastic. Very good.
Yeah, thanks to the .NET team for this.
Oh yeah, it's .NET approved. So I want to talk a little bit about, again, what 2.0 enables us to do. So there are many hosting models, so I want to highlight some of the new ones, but let me start with the range of what we have. So the one most of you are used to and love is your serverless functions, where you deploy your code. As events come, it scales elastically as much as you need, scales out and then back in. And that one, we take your code, we host it, runs on a VM. That VM runs on top of app service, which is Windows-based. And this works great, serves a lot of scenarios, but there are some scenarios that are better served if we host that and deploy as a container. You're still telling us what your code is. What we do is we package that as a container, and we run it on Linux. Now, with Service Fabric Mesh being on preview, we can run on top of that infrastructure, which gives us the instances quickly and dynamically that functions needs to run in the cloud. So this is both the Linux, this serverless Linux stack is also, we're previewing here at Ignite, so it's brand new.
So that's consumption on Linux, is that what you're saying?
That's consumption on Linux. And one of the motivations we had to go after this is some languages, if we have to be honest, they run better on Linux, or they have modules that are specific to Linux. So that will allow us to bring that sort of power to Linux. And you're going to see as we light up more languages, some of them will show up on that Linux offering more and more. So that's new. The other one we already had was, if you have your function on your your dedicated app service plan, you could have a Linux app service plan. Functions work that way as well. In that case, you can bring your code or you can bring your container. A little change we did to our tooling is you can develop your functions, and by using our command line tools, you could deploy your functions to your Kubernetes infrastructure. So let's say your company already invested in Kubernetes. You're using, let's say, managed Kubernetes, in this case, AKS, and you still want to have that nice experience of functions, respond based on events, all the functions as service niceties. You can deploy that to your Kubernetes cluster. Either if it's managed or not managed, this other one just says because it's open source, you can deploy to your Kubernetes cluster running in another provider. I don't know why you would do that, but or your own Kubernetes cluster that you manage, or your own VMs. We actually have some pretty large customers that do this. They use our runtime in custom ways on VMs because they like the functions programming model. One that I feel like we don't talk enough about is the functions running IoT. Right. I know we have some demos. You see functions running on Raspberry Pi. But the way this really works is by this ability we have to package our runtime as containers and deploy to those, either IoT Edge as a product or just to IoT devices as well. And the last one is some companies, and you can see the gray kind of going down. Gray is what the platform managed, and what doesn't have a gray background is what you manage as a customer. The on-prem one is some customers want to bring their own hardware. One case that we have is a customer that runs shipping containers. So they have containers, software containers on top of shipping containers. I know it gets complicated, but they manage their own hardware and they use Azure Stack in that scenario. So and functions runs all the same. So a lot of the things you're seeing here in terms of the tooling, the debugging, and all that, you can do it all the same way. Those are just different hosting models.
So with all of those options now, what's a good example of what we can do?
So we want to do a Python demo. I don't know why, Florida, I thought sharks would be a good demo. So that's what I'm going to do here. I'm going to show you the code first.
This is a Python demo running.
It's a Python demo
on some of the one of the new hosting options that we have?
Yes, so that one will run on Linux consumption. So let me go first through the dev experience, and then we'll go into the hosting part once we try the demo out. So what I have here, and I already opened this project, and what I have is Python code, because some of you are not familiar, but it's just like a function. So you have your trigger, it's going to be HTTP. I receive a HTTP request. I have an HTTP response as the output. And this is based on the model. What's going to do is whatever image URL you pass in, we're going to run our prediction model into it. And the prediction model will tell whether it's a shark or a PM or a dev on the functions team, which is, I don't know how these things come together, but makes a lot of sense. But just to show what you can do with Python, the model itself is not the main point. But what's interesting is it's very common for Python developers to do machine learning. So the way we did this here, use custom vision to train a model. When you use custom vision, it outputs the model file, which is this model.pb here, and outputs the prediction script in Python as well. So that all can be packaged and run in a functions. And if you have any specific Python dependencies that it's needed for your application, you just need to use requirements.txt like you normally would if you're a Python developer. What we do on the Python language worker, we run pip install, put everything in your environment, and we deploy all the assets that you need to get it to the cloud.
So something that's familiar to Python developers, right?
Yeah, absolutely. So, and you can see here some of the machine learning pieces here that's needed by this application.
So let's look at it.
Let's look at it. So what I have here is just my endpoint that I deploy that. If I pass on an image, so let's pick an image of a shark. I had one here. I'm going to just get the address and pass to this thing here to see what it predicts. Oh, sorry, hold on. I did autocomplete from my previous demo. Let's try this again. Okay. This was an actual shark. Let's see what it's going to say. So, and here the prediction model is going to give you just the probability or the confidence level that it is one of the categories we trained on. Let's see if I did something wrong. Here's here.
And again, this is running on consumption on Linux, running with the new language worker deployed on Azure, right?
Yeah. Yeah, I want to make sure I didn't do anything wrong. The previous time I passed something wrong, so it was a 500. I probably did. But what's important here is to understand that this you do all the same. And when you do a deploy here from Visual Studio Code, when you pick where you want to deploy, you're going to be deploying to that infrastructure without you having to do anything different in your code. You can go to a different hosting model altogether. So let's go back here and just give you some links if you want to try things out. So, and I'll have a set of links later. I created a page on GitHub that has all the links that are relevant. But if you want to try Python out or Linux consumption, then you can use one of these links. If you want to try functional Kubernetes, there's a great blog post Asaveri wrote that goes through how to do that with our tooling. All right, durable functions.
Durable functions.
All right, because I feel like we can't, come here and not talk about durable functions.
Yeah, if it's an advanced talk, you have to talk about some of the advanced scenarios enabled by durable functions, right?
And we all love serverless functions, and the fact that we want to write things that are stateless, they're async, and they're short-lived. Ideally, they're even idempotent. But there's some scenarios where you need things that control state, pass state on from one execution to the next, or you need things that would take more than just the 5 or the 10 minutes that a regular function could run.
All right.
So in some of these scenarios, just to illustrate the point of what it's hard to do is, If you have just a simple sequence of functions that have to execute, that's a little hard to do. You have to coordinate that. And when errors happen, propagating that error back to the original caller, that's hard.
It's a lot of work to make that happen, yeah.
If you want to do more classic ones, just a fan out and fan in, especially the fan in, it's pretty hard to do if you don't have the right mechanisms in place. The other ones, a function typically gets triggered by a single event, but what about if you want to run some code once you have multiple events happening? How do you coordinate that? And there are additional patterns you can do here. Last one is if you have a function that do something and then wait for a person, a human, to perform a task to continue, 10 minutes might not be enough. You cannot count on a human acting that fast. So how do you wait and you're still serverless? You don't want to be paying for sort of being awake for that entire time. That's where durable functions come in. The durable function is really a way for you to write your long-running orchestrator while still having the local state that you can pass on. So now, the simplifies really a lot of complex code. Like you can go from a lot of lines of code to a much simpler and easy to maintain code that's easy to understand and much more powerful. It's a code-only approach to do orchestrations. I mentioned logic apps earlier. That's your design-first approach where you can drag and drop your components. But here, if you want something that your orchestration itself needs that flexibility that only code can give you, or you rather write it in code, durable functions is a great product for you.
So it's an imperative way to define your workflow. And again, it's GA, right?
It is GA. It's always good to say what's GA. So, and a lot of our customers already use it for GA purpose. Actually, I have a session later today. We talk about this. Some of the customers using durable functions in production. But for those of you that might not be familiar with durable, and before I go into details here, how many of you used durable before? Just so I have, okay, so some of you did. For the other ones that didn't, I'm going to explain some of the components here. So durable has mainly 3 components. There's a starter function that can kick off your orchestrator. Your orchestrator is the function that can run for long and control state. And as it needs to call into different functions, those functions are called activity function, which in our world of functions is just a different type of trigger, is an activity trigger. And as it needs, it calls into all these different activity functions. The way the orchestrator code looks like, which is the middle box of the previous picture, is you have something that looks like a function. If it has this durable orchestration context, that's your orchestrator function. And what durable function does is every time you want to call into a function, you call the call activity async, and you put in a wait clause. Now you can call those functions. This particular code here, you also can pass in the state from one function to the next. So you see that function 1 returns a state that I pass on to function 2, and that one returns a state that passes into function 3.
So every time you hit one of those awaits, some magic is happening for you. State is being persisted. That function is being invoked. This original function goes to sleep. You're not paying anything for it.
Absolutely.
While the activity is executing.
That is the magic. So we keep all that state of what's happening with durable function in storage, so we know which step to execute next, what has been executed, and what needs to run on your next line of code, if you will. The other thing that's easy here is if any of these functions have any errors, I can just have a single try catch here to catch any issues and respond back with that without having to pass errors back and forth in between those functions.
So that would be the orchestration result.
Yeah. So I have a very simple demo here, which is, it's called durable function, but is it really durable? And I'll show you what I mean by this. I'll test the durability of durable functions. So I'll go into a different demo here, and if you use Visual Studio, you can create pretty much this demo. It's just basically the hello world for durable functions, which says hello to 3 different cities and calls them in sequence, right? So the only thing I've done, my contribution here, was to create this timer here to add a little bit of a delay to give me enough time to kill the host process, just to see if it's truly durable. One thing that's worth calling out here is the way I'm actually doing the delay here is by using the durable context. This durable context, because the durable function is going to replay itself, it's going to check what's in storage and run multiple times, you need to use this context, which is also stored, for you to, instead of you doing a property that can dynamically output a value. You want to have a predictable execution of that same line of code.
Right, because this code may be executing multiple times in the duration of that orchestration every time we replay.
Yep, absolutely. So this context here gives you all these properties like current UTC date time. So all that it does is the orchestrator function and the hello functions, as simple as it gets. You just saying hello to the name of the city. And there's a starter, so I can call the starter from as soon as I invoke my functions host.
Okay.
So let's invoke the functions host first.
And just so you know, all of my demos worked so far. So
I love the pressure. Are you listening to that demo? Okay. So now what I have here is it detected my starter function as an endpoint. So I'll hit this endpoint from Postman to get that function running. And I have this here already. And as soon as I run the starter, it gives me an endpoint that I can check on the status of my execution. So if I check the status of the execution, you see that the function is running, and I'm going to kill this here. So I'm going to kill the host. So if I check the status again, because I just killed the host, this should fail. This failure is on purpose, just to be super clear. So the host is not running anymore. So if the function is truly durable, by the time I bring up my host, it will know to which point it executes the orchestrator and continue from that point on. That's when you cross your fingers. And now you're going to see the logs coming through. So you're going to see the saying hello clauses coming here. So it means executed. I mean, there's the timeout I added, so said hello to another city here. So the function continued to execute. If we check that endpoint now, it has the function being completed. So durable is truly durable. Thank you, thank you.
And you made the point that JavaScript for durable functions is in preview now in 2.0.
It's in preview, and it's another one we should we're sort of on the final stretch to take it to GA as well.
So that's great. So Node developers now can take advantage of the same capabilities, which is
a great
fantastic.
call out. All right, so here's the main things I'd like you guys to take away. I know in terms of pictures, instead of adding all the links, actually what I did is I want to make sure you can be successful with functions, whether you're a beginner or an advanced user. So we put a bunch of links into a single place. I'm going to go here and show. So there are resources on the functions documentation, on durable functions. We went in details 1.0 and 2.0 differences, but there are even more on the documentation, which is fantastic. Something else we launched recently, which is a bunch of ready-to-go simple code, which is serverless community library. So if you don't feel like starting something from scratch, you should definitely check that out. Some basic resources to learn serverless, how to sign up for the preview, how to get in touch with us, and how to do the Kubernetes thing I mentioned about, and the blog post that summarizes our GA. So all of that's there on this link here. The last thing I want to mention again, we talked about open source, and that's why we did this session, to give you the details that's behind the covers, but we only get this far with the amount of excitement we get and contributions in terms of feedback, PR, bug being filed, harassment over Twitter, whatever it is. We love all types of feedback because it makes the product be better. So thanks to all of you that contribute to us. Again, if you want to keep contributing, some more links below. And here's sort of the guide to the sessions. If you haven't seen some of those sessions, I recommend going back to the stream and checking if you're into Python machine learning. Great sessions there. Definitely the enterprise one, with Jeff and Matthew we talked about. And there's still one more, 10:45 tomorrow. And if you want to see how customers are using functions, I'm going to be back on at 12:45 with Thiago.
And we have a webcast, a live webcast from Ignite.
That's right. That's right. There's
right?
a Channel 9 studio that we're going to be broadcasting from there. And
at
yeah.
2:15, somewhere around that time.
2:15, yep. So this is a new format for me and Fabio that we've done, 400 level sessions. So as usual, we appreciate feedback, but tell us how we did so we know whether we do more of those, maybe focusing on different topics like scaling, cold start, and whatnot. So, and we know what to bring next time we're in a conference with all of you. That being said, big thank you to you all.
Thank you.